Hello and welcome to CIT15, week number 3. I'm Todd McLeod. I am your instructor in this class, and I am glad you're here. Today on the docket, we're going to do two things. It's kind of what we do every week. First thing we're going to do is I'm going to review for you what you need to do. I'm going to show you what you need to do this week, just in case you have any questions, you know what you need to do. And then the second thing we're going to do is I'm going to kind of give you some more material to think about. Teach you some stuff. I'm going to lecture. So that's what I can't talk. It's late Sunday night. Do this when you can do it. That's what we're going to talk about. Welcome. I'm glad you're here. Okay, so week number 3 in Canvas. What you need to do is you need to do up through all of your assignments. Week 1, week 2, week number 3. You want to get all those done. You can see there's less of these now. I kind of give you a lot at the beginning because then you get through it. And then you have less to do as other classes get heavier. So I front load this class. And so do all those assignments through week 3. And then in discussions, you need to post a week 3 discussion. And the dangers of texting and driving is so important. Even though tech is a tool, was week 2 discussion. Week 3, I want you to specifically talk about that. And I don't know what the prompt is. Let's see. Watch this video. Great. It's right there. Does this video change the way you think about whether or not it's okay to use a cell phone driving? Will this video influence you to not use your cell phone while driving? So that's the discussion. Make sure you do the discussion. And then come into my IT lab or My Lab IT. It used to be called My IT Lab. My Lab IT, come into there. You should be done with the Windows exam right here, right? You should be done with that one. And you should be done with Word 1 exam. And this week you need to do Word 2 exam. And then come down here into these exams down here and click into the chapter quizzes. And you should do through chapter quiz 3 because we're going to go through chapter 3 tonight. That's what you need to do this week. So now let's jump into talking about computers. And last week, you kind of just take a look at what we learned. There's what we learned last week. And then this week, we're going to learn some more stuff about hardware. So we'll talk a little bit more about hardware. And then we'll cruise through chapter 3's, of the textbook, just see what it says. I kind of talk about this stuff in a different layout than the way the textbook presents it. So you'll hear kind of the way I go through the material. And then the textbook's going to be going through the material. And sometimes those are going to coincide, but sometimes they'll be staggered. And that'll make sense. But what that means is there'll be a little bit of repetition at times. You'll hear me kind of present it in the fashion, the chronology, if you will, that makes sense to me. And then we'll also get the textbook's chronology. So going back to this deal here. Last week, we learned that, what did we learn? So the reason computers exist, right? The purpose of computers is to take data and turn it into information. And there's 4 functions of computers, and those 4 functions are input, process, output, storage, IPOS. Those are the 4 things that computers do. And if we look at the ontological structure, how we break understanding computers up into different categories, there's 2 main parts to computers. Those 2 main parts are hardware and software, right? And then we could break hardware down into, is it input hardware, processing hardware, output hardware, storage hardware. So hardware and software, hardware, IPOS, software can be broken down into application software or system software. And then system software can be broken down into utility software, utility operating systems, utilities, and drivers, right? So that's what system software could be broken down into. So the purpose, data and information. 4 functions, IPOS. And then ontological structure, hardware and software. And then we could further break down hardware and software. So those are kind of the fundamentals. And then we also looked at, how computers work. And so computers run on electricity. Electricity has 2 discrete states, on and off. And we could create coding schemes to represent what on means and what off means. And so this is just like your porch light on Halloween. If it's on, it means one thing. If it's off, it means something else. But then just multiply that by bazillions of little on-off switches or circuits or transistors, right? And you kind of have the essence of how computers work. And so that was last week. So this week we're going to take a look a little bit more at hardware and so how some of that stuff is laid out. In particular, we're going to look at computer remembering. Computer remembering. So let me just kind of position this. I'm going the wrong way. There we go. And so I call this computer remembering because storage and memory mean two specific things. When it comes to computers. Storage and memory do. So I call it computer remembering. And we learned last week that it's important for computers to have some sort of memory, right? Some sort of storage. So I gave you that example of 2 plus 17 equals 19. Well, just like you have to receive input, store that data as I give it to you, right? And then you process that data, 2 plus 17 is 19, and then you produce the output, 19, you speak it, right? Same with computers. As you give them input, you input things, input data, they have to store that data. They have to have some way to remember stuff. And so having computers be able to remember pieces of data is really important. And there's many places within the computer where things could be remembered. And so one of those places is memory, right? And memory is also known as random access memory, and that is also known as RAM. Okay, that's what RAM stands for, random memory access. And that's sometimes also even called primary storage. So, you know, you could hear it referred to, nobody ever in the real world refers to it as primary storage, but on tests, they will call it that sometimes. And then over here we have secondary storage. Secondary storage, okay? And secondary storage would be like, you know, there's 3 categories. You have magnetic, you have optical, and you have solid state. And so magnetic is like your hard disk drive or, you know, tape storage. Optical will be like a CD or DVD, right? It's using optics or light to store the data and to read the data, lasers. And then solid state is like flash drive, thumb drive, or a solid state drive, okay? And so, you know, these two, you could kind of have one or the other, or both, right? But those are kind of like your large barns, your large warehouses where you store a whole bunch of stuff. And yeah, and so, you know, and the trade-offs between them is a hard drive will store, a hard drive is less expensive, but it's slower, okay? So it's less money, less speed. This is more money, more speed. It's kind of like cars. If you want a really fast car, it's going to cost you a lot of money. The faster you want to go, the more you got to pay. And here, this, you know, the less you pay, the slower you go. And one other thing is this has moving parts, and this does not. So with moving parts, that is more fragile. It could be damaged more easily. This is more robust. And so that's the other thing. And this is faster. I already said that. So this is all secondary storage, and it's non-volatile. Non-volatile. And what that means is when the power goes out, what's stored there is remembered. Everything over on this side, everything over here is volatile. And we're going to list a few more things over here, right? And that means when the power goes out, everything that is there, gone, okay? And so random access memory, it works while the computer's running, and then done. So everything, all of our programs, all of our data on our computer, sometimes data now, or a lot of times data now is stored on the cloud. But, you know, like you might have Adobe software, right? Photoshop or, you know, Premiere. And so that software is stored here on the hard disk drive, as is your operating system. And then when you turn your computer on, all the software that's stored either on your hard disk drive or your solid state drive, right, gets loaded in to random access memory. So this is working memory. It's working memory. It's where the stuff that a computer is working with is stored. And you could access this more quickly than you could access stuff out here in secondary storage. And so there's you know, a relationship here between where things are stored and how quickly you could access it and how much can be stored. And so here's your CPU, okay, your central processing unit. That's what that stands for. And when your CPU is working, right, it needs to be able to really quickly kind of get stuff in and out. And so I could do that real quick here because that's fast. It's all electronic. It's all, it's just quick and it's close. And so this is where things that are being used while you're, looking at them on the screen or running a certain piece of software, that's where all that data is stored. When you're not using something, it gets stored out here in permanent storage. Or when you save files, it gets stored out here in permanent storage. Then you want to work with a file, brings it into RAM. So you could store more out here, right? This is kind of like the barn, but it's on the back part of the property, so to speak. You could store more out there, but it's slower access. And as you move this way, you store less, but it's faster for the CPU to access it. So there's this thing called virtual storage, which, or virtual RAM, and that was kind of like pretending that this is RAM, kind of tricking the computer, and you'd store stuff in your hard disk drive if your RAM filled up. It's kind of like back in the day, but it ran super slow because it was all the way out here. You had to go all the way out there to get it, so you had to wait, slow processing, and this is much faster. The main takeaway here, secondary storage, permanent. Power goes off. You remember it. You store a bunch of stuff out here. Slow to access it. Primary storage, non-volatile. This is non-volatile. The power goes out. It remembers it. Primary storage is volatile. Power goes out. It forgets it. But when you're working with something, this is your working memory. You bring it out of secondary storage, put it here, and then the CPU goes back and forth between RAM to get the data, to do the processing, and it's faster, right? And then inside the CPU, when the CPU is doing its thing, like the cycles of the CPU, fetch, decode, execute, and store. When it's going through those machine cycles of the CPU, not really important to know. Later, if you decide to become an engineer, computer engineer, you'll learn more about that. But inside here, there's places where when the CPU is working, it's storing stuff. So one of those places is registers. So it stores stuff in the registers, and then another thing that it stores stuff in is called cache. And cache can be right inside the CPU or just outside the CPU, right? There could be some cache right here. And this might be L1 cache or L2 cache or L3 cache. They have different levels of cache, but that's also a place where computers can do remembering. So these are just the different places where computers can remember stuff as you give it data and as it starts to work with it. It could remember stuff in cache, which is right inside the CPU or just outside the CPU, and there's level 1, level 2, level 3. And the lower the level, the closer it could be to the CPU, the more easily and more quickly the CPU could access it. It could also store stuff in registers right inside the CPU. It could store stuff in RAM. All this stuff is volatile. Power goes off. It gets forgotten. And then out here, it could also store stuff in secondary storage, which is non-volatile. So power goes off. It remembers it. But this is all, magnetic, optical, solid state. Those are the three categories there. And the reason it's great to have a solid state drive, it's more robust and it's faster. You can't store as much there, and it's more expensive. Because it's more expensive, you can't store as much there. I guess if you had a lot of money, you could buy a whole bunch of it. But the reason we like this solid state is because store your operating system here, and it loads super fast. So your computer boots like, bam, up and running. Because you could access it faster than, it's faster than a magnetic hard disk drive. And it's more robust. So we like solid state drives. A lot of times people have a solid state drive and a hard disk drive. So you load your things that you want to load quick, you store them right there, and then you store like long-term data that, you like maybe files of movies you're going to edit or something, you store all those out there. Anyhow, that's sort of the layout of computer remembering. And the farther you go out this way, the more you could store, but the slower it takes for the CPU to access it. And the more you come this way, the less you could store. Like you could store less here and here than you can here. The less you can store, but the faster the CPU can access it. So there's one last piece of memory, and I'll put it down, I'll put it right here. And it's called ROM. And so ROM is read-only memory. And on ROM, something called BIOS is stored. And so BIOS is basic input-output software, or basic input-output system. I can't ever remember that. I've been doing this for a long time, and I'm still not sure. Is it software? Is it system? But BIOS. So basically input-output, basic input-output software, basic input-output system. I think it's system. And what is stored here is, you know, the basic software for doing input and output. So this is right on the motherboard, like all this stuff right here is on the motherboard, including this. Like this is all on the motherboard right here, right? And this is connected to the motherboard via buses, right? Via cables, okay? And with this being right on the motherboard, it is, when you turn your computer on, this automatically starts loading into RAM, and then the CPU can read that, and then this gives the CPU basic input and output functionality. And that basic input and output functionality, what that means is that now your computer can talk to the hard disk drive or the solid state drive. And because it can start talking to the solid state drive, it can load the operating system, which is on the solid state drive. So that's how a computer boots up, right? It gets a basic input and output system software off of ROM, which is read-only memory, though today you can write to it and you could put settings into it. That's what it was called originally, and that name is stuck. And so, you know, all that's stored on ROM, BIOS is stored on ROM, it loads into RAM when the computer turns on. It gives the computer the ability to do basic input and output, which means it could talk to these things out in secondary storage and start loading the operating system. So that's computer remembering. All right. I like doing these things in segments just in case this crashes. I don't want to lose what has been recorded. So I'm going to make this part 1, and in the next video, we will cruise through some of the PowerPoint presentations. See you in the next video. There's 2 parts. You've got part 1. There's one more part to this week's lecture. So that's the next video. Go tune into it.